All right, we are on the 5th section, geometric series. This is our final section. Next class we'll be doing review for 4 and 5, and then which is series, and then we're going to be doing our study guide the time after that, and then we'll have our test. Okay. So, and I will talk to you later. Geometric series. Remember, series is a sum. All right, we're going to have to do some weird fractions, so we're going to get a little bit of practice here on, weird fractions. Okay, so first thing I'm going to do is turn this 1 into a 2 over 2, common denominator. So now I have 3 over 2 minus 1 is 1 over 2. Okay, now I can flip and multiply, and I end up with 6. Woohoo! That was pretty easy. Let's look at this 3/4. This becomes a 3 over 3, which is going to be 3/4 over 3 minus 1 is 2, so I have 2/3. Flip and multiply. And now I've got 9/8. Not too bad. Okay, minus a negative 1/4 becomes plus a positive. 1 plus 1/4 is 5/4. Flip and multiply, I get 4 over 5. 50 divided by 5 is 10. I end up with 4 times 10, so I end up with 40. Okay, geometric series is the sum of the terms of a geometric sequence. We've just went over that with arithmetic. The geometric series S sub n, the sum of the first n terms of a sequence with a common ratio r is given by. So here's our formula for the sum of a series. A geometric series. Make sure you're writing these down on your formula sheet, all these formulas, because you'll need them on the test. All right. Find S sub 10 for the geometric sequence. So our formula is given here. So S sub 10 is equal to the first term times 1 minus r to the n over 1 minus r. Okay, so I have 5 times 1 minus, okay, I'm going to plug 1.5 to the 10 in my calculator. And I get 57. Now remember it said to the nearest hundredth, so I'm going to overshoot it by 2 decimals. 57.6650. Okay? Divided by 1 minus 1.5, which leaves me with negative 1/2. Negative 0.5. Okay, when I flip and multiply or whatever, I'm going to end up with a negative 10 times 1 minus that whole thing. Well, that's going to be negative 56.6650. Now, if I multiply that by 10, the 2 negatives cross out, and that's going to move my decimal place 1 place. So I have 566.650. To the nearest hundredth, the 0 can just go away. I have that answer. And that's all I need. Ba-dum-bum. Okay. Now, find a sub 3 for a geometric sequence with an R of 2 and an S sub 6 of 189. So we plug all that in, we put it into our formula, and now we solve for A sub 1. We know what R is, so we can find 2 and then 3. So we just need A sub 1. So I'm going to use this equation right there. And 1 minus 2, I'm going to rewrite it, simplifying some of this. 1 minus 2 to the 6 should be 64. Yes. So 1 minus 64 is a minus 63 over 1 minus 2 is a minus 1. Those become positive. 63 over 1 is just 63. So what I've got is 63 times A sub 1 equals 189. So I divide both sides by 63. A sub 1, I think, is going to be 3. Yep, A sub 1 is 3. All right, so if A sub 1 is 3, I know that A sub 2 is 3 times R, which is 2, so that's 6. And 6 times 2 is 12. So A sub 3 is 12. And that's my answer. An annuity is a sequence of equal investments or payments made at regular intervals. That's what an annuity is. Okay, the future value of an annuity, there is a way to do this on your calculator, and it's much, much, much easier. So there's this big, long, weird formula you can use, or I think I have a worksheet. I'll post it on this lesson on how to use your calculator to find future value. All right, here's an example. There's so much in the formula. They're a pain. Like I said, I'll post how to do this online. In a geometric sequence where the absolute value of R is less than 1, what happens is that small of an R makes your overall value get smaller and smaller and smaller. We say that R to the n converges on 0. So what that's saying is, let's think about this, okay? If I start with the number 8, and my R is 1/2, when I multiply 8 times R, I get 4. And then I get 2. And then I get 1. Then I get 1/2. And then so you can see that my values are going to get closer and closer to 0. So they converge to 0. If it's greater than 1, it diverges, because what's going to happen is it's going to go do like this. It's basically an exponential. All right. An infinite geometric series, if you think about it, if the number, each successive term gets bigger and bigger and bigger, I can't add it up, because the number I'm adding is just going to get bigger and gigantic, and I can't add it forever. It can't be infinite. But if it's getting smaller and converging to 0, then I can, because you get the number out far enough, and now I'm only adding such small numbers, it's not even going to be noticeable. I'm adding virtually 0. So I can find the sum of an infinite geometric series with an R less than, well, between -1 and 1. So a fraction. All right. Because the series converges. And this is our new sum value for an infinite geometric series. Much easier. You don't have to find that R to the n and all that stuff. Just go back real quick. Yeah, it was the... Okay, so determine whether the infinite geometric series converges. You do that by finding R. So R is -1/2 over 1. It's always any term over the term before. Well, that's just -1/2. So with that R, yes, this converges. I can find a sum. So the sum is the first term over 1 minus r. I'm going to turn, my brain went a little blank. Okay, so my very first term is 1. It's over 1 minus a negative 1/2. Well, 1 over 1 minus negative 1/2 is 1 plus 1/2, which is 3/2. Flip and multiply, I get 2/3. That is the sum, and I'm done. Not too bad. It's pretty easy on that one. All right. A ball is thrown 50 feet into the air and rebounds to 80% of its previous height on each bounce. Find the total distance. So the distance traveled becomes the sum of the geometric series. We talked about the geometric series 2 classes ago for this situation. Well, we're going to take that, and now we're finding the sum of it. Find the total distance its ball travels before it comes to rest. Okay, so we're just going to look for the sum of the infinite series. All right, so 2s is equal to trying to figure out why they're saying 2s. Oh, I know why they're saying 2s. Because the distance the ball travels, if I say the height is here, notice I've got s going up and I've got s coming back down. And then again, and I've got s going up and s coming back down. And each time I have 2 of them. So I have to do twice as many. And I end up with 500 feet. Okay, so that's the trick with that one. It's actually times 2. All right, and we're done. Not too bad. Let me know if you have questions. And I hope everyone is staying safe.